Hello everyone, this is Varun, and I'm here to talk about proof of history in around 20 minutes. So, before we get into what is proof of history, let's get into why proof of history was made. Proof of history was made to counteract Bitcoin's proof of work and Ethereum's proof of stake. So, how proof of work works is it makes everyone mine the same cryptographical function, and whoever cracks the mine for mining first gets the reward. That is how proof of work has worked. A huge disadvantage with this is the huge amount of energy that's required. Bitcoin miners use more than countries in terms of energy, and that has become huge issue in many countries to a point where people have banned Bitcoin mining. So coming to proof of stake. Proof of stake is when a user is supposed to stake an amount of tokens to become a node. And this is used to prevent fraudulent transactions because every fraudulent transaction will remove money from your stake. This creates a loss for the staker, and so the staker doesn't do fraudulent transactions. In this case, first thing, the nodes are very less because the amount of money you need to stake is extremely huge. It's around the range of $100,000 to $200,000 around, or 700 or 1000 Ethereum. And that is a huge disadvantage with this decreasing the number of nodes, which in turn causes the net to slow down. So a solution to this was proposed at Solana Labs when they formed the blockchain Solana. It's supposed to be the most performant blockchain in the world. And these are the stats for Solana. The main reason why Solana is so performant is because of proof of history. We'll get to that later. And first for the stats. Solana has almost 2,240 transactions per second. And if you want to compare that in relation to Ethereum, Ethereum has almost just the power to process almost 15 per second, 15 transactions per second. But even then, Ethereum's popularity is much bigger than 15 transactions per second. This causes huge wait times, around 15 to 20 minutes of wait times, and also high transaction fees like $200 transaction fees at the peak points. Whereas when it comes to Solana, the transaction fees is almost 1/40th of a cent. And also the validator nodes 1532, we'll get to that in a few moments. Ethereum's smart contracts have had a lot of user base, and Ethereum has not been able to keep up with the demand. So, what proof of history proposes? Proof of history proposes that we inculcate the time of the block into the block itself instead of having consensus mechanism for the timing. So, timing in distributed systems has always been a huge issue for everyone, especially in such blockchain systems where every node has to ask the other nodes where the time, what the time is, and when the letter had passed. But when it comes to proof of history, every node that passes a letter will have a stamp on it. Every node that forms a block will create a timestamp along with the block, which shows the lower limit and upper limit of the time that the block was created in. And this makes it much easier to sort out an array and order a blockchain according to the timings. Even though this may not give you your exact time, this will still give you a SHA-256 algorithm of the time, which can be arranged by a computer. The main needs for making a node is VDF, that is a verifiable delay function. It's a very straightforward function, unlike the cryptographical functions of Bitcoin and Ethereum. This does not need too much computation power, and therefore anyone can set up a node with even very less power. Proof of history and a small example. Let's assume we have node 1, node 2, um, node 3, and I'm supposed to get data from all of them. This is my node. And supposing node 1 created the block first, node 2 created the block second, node 3 created the block third. And supposing node 1 has extremely good Wi-Fi, whereas node 2 has relatively poor Wi-Fi, and node 3 literally has no Wi-Fi. So the timings let's assume node 1 has poor Wi-Fi, node 2 has good Wi-Fi, and node 3 has extremely bad Wi-Fi. So we'll be receiving node two's packet first, and then node one's packet, and then node three's packet. So our blockchain will differ from the other blockchain if we arrange it according to the time we receive. So we can't do that. So what we do is we sign the timestamp of the block at the node it's created at. So here I'll have a timestamp that may say, let's assume it doesn't say this exactly, 12, and this may say 13, and this may say 14. And this should make it very clear what order the nodes come in at. And this can help us arrange it in one. This can help us arrange it much easier because this is just a sort function. Sort functions are much more faster than a cryptographical function. This is not the only innovations that come with Solana. There are eight major innovations that are told to come with Solana. This is just one of them, proof of history. The next we'll have to look at is Tower BFT. This is just a Byzantine fault tolerance. This just means punishing people who want to break the system. Because Solana has been extremely good at staking. They have allowed everyone to stake how much ever amount you want. You can stake at very small amounts. You can stake very high amounts. You can stake your computation power because you don't need much computation power for a simple sort. So anyone can stake and anyone can vote on multiple forks of this blockchain using by paying a fees of around 1 sol per day approx that turns out to around $70,000 per year. Many people do that because that helps them get a key into Solana and its interworkings. But any Solana fork that threatens to risk POH is then put through Tower BFT. So what Tower BFT does is it checks every single fork of Solana, and if any fork of Solana doesn't pass the POH, it penalizes the person who approved it and every person who approved it. So this is one of the things that Solana has done to protect its POH instead of from attacks. And also we can now talk about sea level. So sea level, as we know, Ethereum smart contracts are written Solidity or Viper because Ethereum smart contracts run in a virtual machine in miners or validators computers. So when we come to Solana, it doesn't run as a virtual machine. Rather, it runs as an actual code and an actual instance. And therefore, this helps us have multitasking to a point where I can have three instances of my code running, and all three instances can be doing three different things. Uh, Solana coding is written mainly in Rust as compared to Solidity or Viper, and it's completely new because and it cannot all dApps cannot be ported from from Ethereum to Solana. But Rust is a very low level language and it gives great access to all the features that uh, the technology has to offer. So coming back to the eight innovations, Turbine is just a block propagation. It increases the speed. The block times of Solana are extremely low, as low as 400 milliseconds, as compared to Ethereum's 15 seconds, or even Bitcoin's 10 minutes of block time. Solana's block times are literally 400 milliseconds, and this is on a whole new level because this may bring about a revolution. Gulf Stream Assad, we won't be discussing it here, and everything else will not be discussed here. So this is a simple video on proof of history, and I
Proof
suggest
of history enables the blockchain to work fast while maintaining security and decentralization. Here's an analogy. If snapshots of dye diffusion were scrambled, you would know how to place the resulting images in order again because of the laws of entropy as a function of time. Proof of history uses a recursive verifiable delay function to hash incoming events and transactions. Every event has a unique hash and count along this data structure as a function of real time. This information tells us what event had to come before another, almost like a cryptographic timestamp. giving us a verifiable ordering of events as a function of time. Each node gets a cryptographic clock that helps the network agree on time and ordering of events without having to wait to hear from other nodes. Unlike slower, traditional blockchains, oftentimes throttled by various consensus mechanisms, Solana achieves high throughput without sacrificing network security. Visit solana.com to learn more.
As we saw about Solana, this is one of the main reasons why Solana is so fast. It doesn't have to ask other people the amount of time that it takes for Ethereum to validate a block is based on the number of nodes that are verifying it. Where because a multiple number of nodes verify a single block. But when it comes to Solana, one validator verifies one block, and this causes it to be as fast as the validators. And Solana has also put out a really statement that they're not bottlenecked by software or the creativity. They are bottlenecked only by hardware because as hardware increases, Solana's power increases more and more. This is one of the major advantages of POH, and it's the scalability. So, but there are some issues with POH and Solana. It goes down regularly. It's based on completely on validators. And these are the numbers you saw, 1,532 validators, as in they validate your timestamps, they validate your cryptographical functions. Even though it's not a very tiresome process, it still needs computation, but much on a much less scale than Bitcoin. It can be done on any small device, and the value and the returns are also pretty decent. Considering the average cost of transactions and the transactions per second, I would say that POH is a huge success. And one more way of explaining POH that uh, Solana prefers is the train theory. So we have a train going from point A to, let's say D, and it goes to B and C in between. So what happens in a traditional blockchain is when the train goes from A to B, B calls up A and asks whether the block has been passed. And if it has been passed, B allows it to go to C. And C calls up B and A to check whether the block has been passed. And if it did, it goes to D, and D calls A, B, C to check if it's passed. And if it's passed, D approves it and becomes a block on the blockchain. Whereas if so, in case of Solana, A puts a stamp on the letter, and that stamp is proof that A has already seen this parcel. So when it comes to B, B doesn't have to call up A, it just has to look at the parcel and it'll know that A has already seen this. So B puts a new stamp, C puts a new stamp, and when it comes to D, D just checks the stamps. It doesn't have to call up A and ask whether this parcel has come through you or not. And this creates a huge difference in the performance because the number of calls in a huge node can be exponentially huge when compared to just a lookup in case of POH. And this is one of the reasons why the performance has had such a huge bump. Uh, and this, I think, is why Solana can always replace the traditional blockchains. Ethereum is losing out on its performance due to its very high demand, and I think Solana with POH can be a solution because there is no major flaws here. And even if there are flaws, since this is new software, there are many fixes coming up in recent times. There's also hackathons coming up. There's also a challenge of Break Solana, which everyone is welcome to try out. You can put up Sol and you can try to break the Solana blockchain. You can just press, it's just pressing a button number of times. They're so confident that their wallet will not, that their blockchain will not break, that they have put up a competition for anyone with a bounty that if they break the blockchain, they do get paid. And that is a confidence of POH and Solana. And I think it will be a huge deal. And I believe it's a revolution in blockchain. thanking you. This is Varun signing off.